So this is lesson 5.1. We're going to talk about graphing cubic functions. And as you can see at the top, a cubic function, or the parent function of a cubic rather, is this f of x equals x to the third. And then we have these transformational forms which should look very similar to what you've seen before for absolute value and for parabolas, where we've got maybe shifts to the left or right, and vertical or horizontal stretches or compressions. So really what we need to learn first is what does the parent function look like, so we can just apply the same transformations like we've done before. So if we go ahead and use this table of values, and I'll fill that out for us, negative 2 to the third power is going to give me negative 8. Negative 1 to the third is negative 1. Remember, this is like negative 2 times negative 2 times negative 2. 0 to the third is 0. 1 to the third is 1. And 2 times 2 times 2 is 8. And then if I go ahead and plot those, I've got 0, 1, 1, 2, 8. And then similar points in the other direction. So what I want you to see, first of all, you can kind of think of cubics kind of like a twisted paper clip. So it's going to have one side obviously is going to be going up and the other side is going down. That's their general form. And then similar, there is this kind of same pattern to cubics as there is to quadratics. Remember in quadratics, we had this like 1, 3, 5, 7 pattern. Well, that's not going to be our pattern here in cubics, but you may notice in cubics, you have this 1, 7 pattern. So it's like down 1, down 7, and then the other direction is up 1, up 7. And we're still going to be going over 1 every time. So if you want to write that down, the vertex or that like middle point is going to always be 0, 0 in the parent function. And the pattern for the parent function is going to be 1, 7 over 1. And that is, if you may even need to write plus and minus so you remember that it goes different directions. And so if we talk about domain, range, and behavior, kind of talk about these attributes that we've talked about before. So domain, all real numbers, right? This is going to the left and to the right forever. Our range is also going to be all real numbers because we're going to be going up and down forever. If I label my in behavior, this is going left and down. And then I've got right and up here on the other side. So this says as x goes to positive infinity, which is to the right, it's going to go up. So that's also positive infinity. And then as x goes negative infinity, that's the same as left. So that's going to be down, negative infinity. The zeros of the function, that's where it crosses the x-axis, is at 0. Where the function has positive values is where x is greater than 0. Negative values is going to be where x is less than 0. Where is the function increasing? This increasing, remember, goes from the left all the way to the right. So even though you've got this arrow on the left-hand side, if I read from left to right, this is increasing on the entire function. So that's going to be on all real numbers. Or that one may make more sense to you from negative infinity to positive infinity. It's increasing the whole time. Where is the function decreasing? It never decreases. And then is the function odd or even? So this we're going to call, part of this I don't really want you to pay attention to, but you can just make a little note here that this has an odd degree, because that's going to come in handy during our next lesson. So make a note that this has an odd degree. All right, so let's look at how to apply this parent function and do some transformations to it. All right, so I've got two examples for you here. Just like we did with quadratics, our first thing we want to do is name our vertex, and it works the same way. Inside's the opposite, outside's the same, so this becomes positive 1, negative 1. And then we want to name whatever any multipliers, stretches, or compressions are doing. So there's a 2 on the outside there, so outside is going to be vertical, means I'm going to keep it the same, so that's still a 2, and that's going to become a stretch. So if I think about my pattern, which is, remember for this one, it's like plus minus 1, 7 over 1. Vertical, that's rise. So that means I'm going to multiply this top pattern by 2. So when we go to graph this, same way we did the last time, we're going to start at our vertex, which is 1, negative 1. And I want to go, instead of going up 1, I'm going to go up 2 over 1. And then similarly, I'm going to go down 2, backwards 1. And if I had enough room, I would go up 14 next, which I don't, but I'm going to make a point kind of way up here just so you get the picture. And then down 14. And you may want to like make a note that you're going down 14 and up 14 just for yourself. And then you're just going to connect these points. If you don't have enough to connect, like since on the graph I can only fit 3 points, you just want to make sure that you make it look curved and not look like it's just a straight line. And the way that I do that is I usually like connect, notice I do the vertex and then that point, kind of like half of a parabola, and then I make the other half the parabola, which it's not really, but go downward. That way it looks curved. All right, let's try question B here. So again, I'm going to start with the vertex. Inside's the opposite, outside's the same. That gives me a vertex of -3, 4. I have a 2 on the inside, all right, so that means I'm going to be looking at a horizontal this time because I'm inside, which is opposite, so this is 1/2 now, and that's going to be a compression. So I'm going to think about, right, my standard pattern is +1, 7 over 1. Horizontal means I'm going to change this run part to 1/2. So let's look at what this looks like. I'm going to start with my vertex, -3, 4. Let's see, so now I am going to go up 1, but I only want to go over 1/2. And then I'm going to go up 7, which I don't have enough room to do here, and over 1/2. All right, if I go the other direction, I'm going to go down 1, backwards, count correctly, down 1, backwards 1/2, and then down 7, 1, 2, 3, 4, 5, 6, 7, backwards 1/2. So I'm still, this really should remind you a whole lot of quadratics. The only thing different is the pattern that you're applying and what it looks like. All right, so there you go. That's my transformation. All right, and the last thing I want to talk about, which I think that now that we've done this transformation stuff a few times, you should be getting better at it, and I think you should be able to do this step. And this step is to write the equation. So they're going to give us a graph and name some points for us and then ask us to write something. So the first thing we know, the same way the other way that we did, is name the vertex. So here I see my vertex is -2, -2. And then I want to see what is changing in the pattern. So remember, my typical pattern is like up 1, over 1, and then up 7. I notice that this is not going up 1 in the beginning, it's going up 3 and over 1. So to me, that makes me think that this top pattern, this ±1, 7 over 1, the top part is maybe what's being changed, and it's being changed by 3. And I know if the top part is being changed, that's my rise, that is going to be a vertical change. So it's going to stay the same. So when I go to write my equation, I think the equation, they're telling me to use g of x up here, so that's why I'm writing this. G of x equals, it's a vertical stretch of 3, so that's going to be a 3 on the outside. Inside should be opposite, so I'm going to write x +2 to the third. Outside's the same, -2. And that should be the function that gives me this graph right here. And if this was a calculator question, you could always use your calculator to like check, and I can show you how to make a table of values to make it check for you. All right, this other question, kind of same idea. We'll start with the vertex. So I'll name the vertex here in the middle, which is 1, -1. And now I notice I am rising 1, but my run this time is 4. So that makes me think this +1, 7 over 1, that the run is being multiplied by 4. That is an example of a horizontal stretch. So when I go to write my equation, I'm going to have g of x equals, if it's horizontal, it's going to be on the inside, which they kind of give you the hint about in the form, but just so that you know in case you don't have that hint. Horizontal is opposite, so since this is a 4, I want to switch that and make that say 1/4. And then inside is the opposite, so x -1 to the third. Outside's the same, -1. All right, so make sure that you have these notes for yourself. Make sure that you've included the graphs, at least a few of the, even if it's a rough sketch, but you have the 3 points named, you're going to want to know like where we came up with these equations when you go to do these problems on your own.